Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Azlan Shah bin Suhaimi, Matric number 1729443. Now I'm going to present about final year project 2 regarding PC to handphone LIFI communication system. My supervisor is Dr. Suriza Ahmad Zabidi. Introduction. In the new era of 5G, LIFI opens a new way of wireless communication. Basically, this existing technology uses LED lights to transfer message wirelessly. When multiple devices are connected using the existing wireless network that connect to the internet are very slow in various situations. LIFI is a 5G electromagnetic spectrum system that uses light as a source to transfer the network and wireless communication that's similar as Wi-Fi. LIFI could take us to the Internet of Things (IoT), where everything is dealt with electronics that have light as a source on the devices. It can be used as LIFI Internet access point. Problem statement. As we know, if there is a new technology that had been introduced, many problems and difficulty will occur due to their nature consequences. Same goes to LIFI that people will doubt to use it because it is not commercially advantageous. The main problem is that LIFI cannot penetrate through objects because it always needs light to maintain the performance. Therefore, the existing LIFI technology can cover up to 10 meters of range. If the person is outside the range, there will be no signal for it to receive the information. This is the reason why LIFI only used in the small room or small space such as in airplane. Compared to Wi-Fi, it can cover more distance in order to access the internet. If the distance can be increased, imagine everyone can enjoy the highest speed of data rate transfer with the involvement of multiple devices. Hence, the performance of LIFI need to be kept and enhanced in order to make the system strong. Objective. Therefore, there are two objectives that I want to achieve in this project, which are increase the range of LIFI higher than 10 meters using laser diode. Second one is keep and enhance the performance of LIFI. Literature review. LIFI is a main application of visible light communication (VLC) that carries message by modulating light signals around 380 nanometer to 750 nanometer in wavelength. Because of its higher frequency, LIFI utilizes light LED, which is example of visible light for transmission purpose. One of the characteristics of visible light is it cannot penetrate through obstacle and object. Hence, no inter-cell disturbance problems beyond the partition can occur that allow visible light to create a small cell of LED transmitter. LIFI consists of a ALC transmitter and a VLC receiver, making it a complete wireless network. The components for visible light communication are transmitter and receiver. For example, LED. Basically, a VLC transmitter is used to transmit the message in the form of light. It will convert the digital data into visible light. In the transmitter, an LED is being used to transmit the data to the receiver at high frequency. Based on the figure, there is a digital signal processor, which is an LED that will modulate digital data through the optical medium. It also controls the flowing of the current through LED to control its brightness. While white light is most commonly used as the best source of light source. White light can be produced using blue LEDs with phosphor because it is easy to implement and provide low cost. Technically, a VLC receiver will receive the information from the transmitter. The receiving circuit consists of amplifier, optical concentrator, and photosensor. Light that is emitted from a transmitter is generally weak because LED illuminates large space. Optical concentration will pick the weak signal and the amplifier will amplify the signal. Then, photodiodes will detect the signal and convert it into modulated photocurrent. In the devices that have a decoder, it will translate the modulated signal into understandable information for end user. Methodology. This research is focusing to enhance the range of existing LIFI technology as mentioned before. LIFI uses LED as the medium of transmission. There are two important things that need to be highlighted, which are the use of laser diode as medium of transmission and the application of low-frequency light modulation. Basically, to improve the range, the proposal is to build a new circuit that can modulate light with low-frequency signal from the input pipe, which will get signal around 20 Hz to 20 kHz. This signal passes through C1, which contains one ultrafiltration electrolytic capacitor, which direct current components are removed. After that, the signal goes through 10 kΩ of R tier with current limit for op-amp, then through 15 kΩ of R1 and 50 kΩ of R4 with voltage limit to 4.5 volt. The function of potentiometer is for feedback gain controller to control message at output to base of transistor. The transistor works as modulator and amplifier as C3 and C4 are filtered to reduce alternate current component spike in the circuit. We know that carrier wave can take the signal along to the destination. The concept is when the photon with the speed of light carried by laser diode to destination, it can also carry signal of low frequency to destination. Therefore, the idea of solution is to build a circuit which can modulate light with low frequency signal. Laser diode is a semiconductor device which can directly convert electrical energy into light energy. A laser can create lasing condition at the diode's junction when diode pump directly with electrical current. In this project, the use of laser diode over commonly used LED because laser diode only has a single color, while LED consists of various colors with different intensity. Another different key is that the concentration of charges carriers is very high in laser diode, while in LED it is very low. Although the cost of laser is much higher than LED, laser diode give more response to the system. The model of the system is designed and explained in the above block of diagram. The planning is to make one PC at the transmitter and one handphone at the receiver, two microcontrollers at both ends, and a laser diode at the transmitter. And a light-dependent resistor at the receiver end. Information are being transmitted using modulation technique, which is amplitude shift key. Firstly, the LDR will detect the light from the laser diode if the corresponding voltage value from Arduino exceeds a predefined value, which is 5 volt. There are two possibilities for the laser diode, which are shine strongly and shine weakly. If it shines strongly, the LDR will detect it as binary 1, and if it shines weakly, the LDR will detect it as binary 0. This is called on-off keying. This is a simplification of amplitude shift key. Basically, Arduino Uno viewed as a state machine that have two states. The first one is for synchronization and the second one is the content of the machine. In the synchronization state, the receiver will wait for a fixed bit sequences. It means the receiver must detect now because the text message followed. Conclusion. The proposed solution is to build a low-frequency light modulation circuit that can increase the range theoretically. The help of laser diode is also being used to test the system whether it can reach the distance. In terms of range, the objective cannot be obtained because there are many components that cannot be obtained and the theory are not proved yet. To enhance the performance of LIFI, this objective has been achieved successfully after doing the experiment. The message can be transferred in short of time with light as the transmission medium.